I want to show you the motivation behind it, but I don't think it's kind of neat where it's insightful where it comes from. And so, an exact differential equation. Exact differential equations are of the form f of y equals g of ty or dy dt is equal to g of t comma y over f of t comma. So, what I want to try to do is explain the motivation. So we're going to start with the idea. Here's how this goes. Oh, just to let you know, so Johnny has posted some of the videos from class. So for those of you that are looking for those, you just go to the Canvas site, put a link up there, all of those. So if you want to go back and watch the videos, please do. If that helps, that'd be great. Thank you, Johnny.
Thank you, Joe.
Has it gone viral yet?
Not yet.
Yeah, right. The idea is, let's do this. Let T, capital T of T and Y equal. Now, I'm setting this up. I'm setting this up by design. And it's going to look difficult, and then as soon as you see an example, I will try to clarify it so you can see where the motivation came from. So let capital T, and this is of time, and then remember y is still y of t, equal g1 of I'm sorry, g1, I didn't think about that. g1 of t, oh no, erase that. Yeah, I'm going to use G, just because that's the way I practiced it, but we're gonna, that G and that G are not the same kind of G's. Why are they? And so, G1 of T, F1 of T, plus G2 of T, 2 of Y. Did I see? Oh, that's a Y. Goodness gracious sakes, Y. I'd be at it all night unraveling that Y. Okay, so at this point, and I'll make a note, for simplicity, we stop at G2 and F2. But you could go plus, you can have more of these, plus G3 of T, F3 of Y plus, and you could go all the way out to N of these if you want, okay? And I just don't want to write that many, but 2 of these is enough to immediately see how the pattern is.
What would that be for us?
If you were going to prove this, you would need to write them all out. But I just need to just get the motivation for it. So we could write them out if you wanted to see more of them, but it's just all after a while you're like, I'm tired of writing. But when you want me to do it, I can talk about it. I don't mind. I just figured you'd be like, okay, I get it. Dot, dot, dot. I want to bore you guys. So if you want to try it like we created at home, just put plus, dot, 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 you go to G, N, O, T, F, N, O, Y. Okay, so here's what we're going to do. Now, differentiate T, differentiate t implicitly. Implicit with respect to t. With respect to t. So if you don't remember implicit differentiation, that's okay, we're going to review it here. And here's how it works. So we're going to take the derivative with respect to t of capital T of t comma 1. So, wait a minute. Right off the bat, what do we hit? We hit a product, don't we? So we have to apply the product rule. So let's do that. So we're going to get a G1 prime of T F1 of Y plus, then we're going to get a G1 of T F1 prime of Y, but remember F is a function of Y, Y is a function of T, so by the chain rule, dy dt. That's our first term differential. See how that works? Okay. Plus, let's do this one more time. So take a moment, write out the second derivative, just like I did that first time. So you're differentiating the G2 F2 term. Write mine up here too as G2 prime of T F2 of Y plus G2 of T F2 prime of Y dy dt. Now, we're going to regroup these based on our G primes and our dy dt. So I'm going to write that next. So I'm going to write this as equal to, I'm going to put a big parenthesis. I'm going to call this G1, I'm just rewriting, so G1 prime of T F of Y plus G2 prime, G2 prime of T F2 of Y parentheses. That's my first group. Plus another big parenthesis. And this time we're going to pick up the terms that have the dy dt's in them. So when I do that, I'm going to get a G1 of T F1 prime of Y plus G2 of T F2 prime of Y, big parenthesis dy dt. Oh yeah, now we're making progress. I wish I had one really good here. This is when you need one of those boards you can just slide up and then out from under is another one. This is equal to, so I'm going to have to come all the way around, over and up. So let's do that. You don't have to do that unless you really want to. If you've got more room below on your paper, you can use that. Let's do this. Notice a couple of things here. This first parenthesis, there's no specific order. We need to make a few observations. So I'm going to put along this curvy line because what it's leading to is what we need to do. And that's we need to make observations. I'm going to call the first set of parentheses G. I'm going to call the first set of parentheses G of t comma 1. Plus, I'm going to call the second set of parentheses f of t comma y, dy. Okay, so in your notes, notice all I'm doing is creating names. This has a new name, f of t comma 1. And this first term has a new name, g of t comma 1. That's all we're doing is giving them names. Oh, yeah. But look at this. Look at this. G of t and y, well, really what this is another way I've taken this. G of t, y is also the same as the partial derivative with respect to t of t. Because this is what we did. All these were with respect to t's that we differentiated. So this whole function was held constant. This whole function was held constant. All we did, because otherwise we would have added up, and this would have been a lot bigger work. So all these was, this was the derivative with respect to t. But notice we're factoring this in. This came from rearranging all these terms.
Isn't y a function?
Why? Yes, it is. But we're doing a partial derivative now.
So was that initially a partial derivative of t?
No, we started out as an implicit derivative, but the result matches what would have happened had we done it using a partial derivative. That's what's going on. And this f of t is the same as the partial derivative with respect to y of t comma dy dt. Because when you differentiate with respect to y, you have to pick up that y is a function of t. That's why this dt is there. Okay. What else? Oh yes. Now, let's try one more thing. Let's try one more. So we said that g, our function g of ty, was the partial with respect to t. So what would happen to g if we took the derivative of g with respect to y? Let's just try it. Let's just try it. So what we're going to do is now, take a moment, take the partial derivative with respect to y of g of t comma y. All right, so let's do this together. So g of ty way over here is right here. Let's do this together. But now we're differentiating just the y parts. So this is just a function of t. It doesn't change. And we're not even worried about t's. T's are being held constant, so we don't have to apply a chain rule here. We're just picking up the partials. So the only thing we have to take the derivative is this y function. So this becomes g1. Oh, I forgot a 1. Should be that 1. So this should be, so our partial is going to become g prime of t times, yeah, did I say g1? g1 prime of t times f1 prime of y. We're just taking the differential of the y component. T is now held constant. So if we come over here and we break that down, let's see, so this becomes G1 prime of t times F1 prime of y. Plus, and then take a moment and write that second term on your own, see what you get. Write that second term. And that second term should become G2 prime of t times F2 prime of y. Is that what you guys got? Okay, because I can't see over here. So now let's try this. So g was initially partial with respect to t, so we now took it with respect to y. Let's try the same method on f of t and y. So f was initially a derivative with respect to y, so now let's take its partial with respect to t. Okay, so let's take the partial derivative of f of t and y with respect to t. Okay, so now f1 prime of y, this is just a constant. So all you have to do is just take the derivative of the t function. So this just becomes g1 prime of t plus, again, a constant, g2 prime of t. That's our result. So let's write that down. So what do I get? I have, well, what did I just say? Did I say g1 prime of t f1 prime of y? Is that what it says? Plus g2 prime of, oops, sorry, of t, that's of t f2 prime of y. Did I write that correctly? I know I did. Do you know what I did? They're the same. Right, this is equal to the partial derivative. Is equal to the partial derivative with respect to y of g of t. That's where exact equations come from. So let me give you the definition of how this works, and then we're going to take a look at how it all comes together and help you to see what's going on.